Hello everybody. In this video we are going to look at the solution to the Physics 1 electromagnetic spectrum due right now, number 3. The problem says, suppose you are a traffic officer and you stop a driver for going through a red light. Further, suppose that the driver draws a picture for you and explains that the light looked green because of the Doppler effect when he went through it. Explain to him using the Doppler shift equation how fast he would have been going in order to make the red light, which has a wavelength of 645 nanometers, to appear green and have a wavelength of 545 nanometers. It sounds like something I would do to a traffic cop. Oh no, it's a Doppler effect. I wasn't speeding. All right, anyways, let's take a look here. So I know that my observed wavelength is going to be 545 nanometers because it tells me that the light appear, or at least the person is saying to the traffic officer that the light is appearing to be green. So that is my observed wavelength. The wavelength of the source, which is the red light, is going to be 645 nanometers. The speed of light, as always, is 3.00 times 10 to the 8th meters per second, and we are solving for velocity. And note here we are given the wavelengths. So I'm going to have to use my wavelength equation. And because the traffic light is stationary and the driver of the car is traveling toward the traffic light, the relative velocity between them has to be negative because the relative motion is toward between the observer and the source. So we're going to have a negative velocity. So when I look at my wavelength formula for the Doppler effect, I know that the observed wavelength minus the wavelength of the source is equal to the velocity between the source and the observer divided by the speed of light times the wavelength of the source. And when I rearrange that to solve for the velocity, I'm going to get V is equal to C times the wavelength of the observer minus the wavelength of the source divided by the wavelength of the source. Plug my known values into that equation, and I am going to have a velocity, relative velocity between the source and the observer of negative 4.65 times 10 to the 7th meters per second. Once again, I explained this in the last video if you saw it. Once again, note that I'm not converting my nanometers to meters here. I don't need to because in this case, they're going to cancel out. I have meters per second for my speed of light. My answer, I want it to be meters per second. So using my dimensional analysis, I know that these nanometers here are going to cancel each other out. So it doesn't matter if I'm in meters or nanometers for that because all those units will cancel out. Once again, you can still convert to meters and know that you're going to get it right. If you just want to play it safe, perfectly fine to do that. You're going to come out with the same answer. So if you're more comfortable doing it that way, that's fine. But in this case, you don't necessarily need to do that conversion.